The 737 rudder crashes. Before the MAX, before the Dreamliner, Boeing had a problem with the 737 that killed 157 people and took most of a decade to properly explain. On the 3rd of March, 1991, United Airlines Flight 585 was on approach to Colorado Springs when it suddenly rolled and dived into a park about 4 miles short of the runway. All 25 people on board died. The NTSB investigated and could not work out why. The wreckage did not give them a clear answer, and the case was formally listed as unsolved, one of only a small handful in American aviation history. 3.5 years later, on the 8th of September 1994, U.S. Air Flight 427 was approaching Pittsburgh when it did almost exactly the same thing. It rolled left, went nose down, and hit the ground. All 132 people on board were killed. 2 crashes, same aircraft type, same sudden loss of control, and still no explanation. Investigators eventually worked out the problem was in the rudder, the control surface on the tail that swings the nose left and right. The 737 used a single hydraulic valve to control it, and under certain conditions, that valve could jam in a way that sent the rudder hard over to full deflection in the opposite direction to what the pilot had commanded. Push the pedal one way, the rudder goes the other. At low altitude on approach, there is no time to recover from that. It took until 1999 for the NTSB to formally attribute both crashes to the rudder design. Boeing eventually redesigned the system, and the FAA required around 2,000 American aircraft to be refitted at an estimated cost of $364 million. The 787 Dreamliner battery crisis. Boeing called it the most advanced airliner ever built, and for a while it looked that way. Then it started catching fire. The 787 was the first commercial jet to use lithium-ion batteries in its main electrical system, chosen because they were lighter and held more power than anything Boeing had used before. On an aircraft designed around saving weight everywhere possible, that mattered. The problem with lithium-ion is a failure mode called thermal runaway, where one small internal fault makes the battery heat up, which causes more faults, which makes it hotter until the whole thing burns. It is the same reason phone batteries occasionally catch fire, except this was happening at 30,000 feet. In January 2013, a battery caught fire on a Japan Airlines 787 sitting at Boston's Logan Airport, found by ground crew after the passengers had already got off. 9 days later, another one started smoking mid-flight on an All Nippon Airways jet over Japan, and the pilots had to divert and land immediately. 2 incidents, 9 days apart, on an aircraft that had been carrying passengers for about a year. Investigators could not promise it would not happen again, and on the 16th of January, the FAA grounded every 787 in the world, all 50 of them. It was the first time the FAA had grounded an entire aircraft type in the United States since 1979. The fleet sat for about 3 months while Boeing worked out a fix, and what they came up with was blunt but effective, sealing each battery inside a reinforced steel box so that if it did catch fire, the fire had nowhere to go, and the batteries were only the last chapter of a program that had already gone badly wrong. Boeing had outsourced huge sections of the 787 to suppliers across the world on the theory it would be faster and cheaper. Instead, parts arrived late, or arrived and did not fit, and Boeing ended up buying some of its own suppliers just to get control of the process. Analysts have estimated the delays and overruns ran to somewhere around $32 billion. The 737 MAX crisis. This is the one that broke Boeing's reputation, and it killed 346 people. On the 29th of October 2018, Lion Air Flight 610 went into the Java Sea 12 minutes after leaving Jakarta. All 189 people on board died. Investigators worked their way toward a system called MCAS, which Boeing had fitted to compensate for the way the MAX's larger, repositioned engines changed how the aircraft handled at certain angles. The system could push the nose down automatically, and it took its information from a single sensor. If that sensor was wrong, MCAS acted on bad data anyway, and it could fire again and again. Pilots had not been trained on it. In many cases, they had not been told it existed, because a large part of the MAX's appeal to airlines was that crews already qualified on older 737s would not need expensive retraining. Less than 5 months later, on the 10th of March 2019, Ethiopian Airlines Flight 302 came down 6 minutes after taking off from Addis Ababa, killing all 157 on board. The black box data showed almost exactly the same pattern. The Ethiopian crew had tried to follow Boeing's own emergency procedure and still could not recover the aircraft. Regulators around the world grounded the MAX within days, and the FAA held out for 3 days after the second crash before following. The aircraft did not carry a paying passenger again for roughly 20 months, the longest grounding in American aviation history. What came out afterwards was in some ways worse than the crashes. Boeing's own engineers had flagged concerns about MCAS relying on a single sensor before anyone died, and that never reached regulators, airlines, or pilots. The CEO was pushed out at the end of 2019. The Justice Department charged the company with conspiracy to defraud the United States. Direct costs ran to around $20 billion, with indirect costs estimated at roughly $60 billion more. The 737NG cracks. In September 2019, while Boeing was already in the middle of the MAX crisis, engineers found something they were not looking for. During modification work on a heavily used 737NG, cracks turned up in a component called the pickle fork. The pickle fork is the structure that attaches the wing to the fuselage and carries the enormous loads passing between them. There are 4 of them on the aircraft, and they are designed as what engineers call a safe life component, meaning they are supposed to last the entire service life of the aircraft without cracking, rated for 90,000 flight cycles. The cracks were showing up on aircraft that had flown around 35,000 cycles, in some cases less. Qantas found cracks on aircraft with around 27,000 cycles. Lion Air found them on 2 aircraft with under 22,000. These were parts failing at a third of their design life. The FAA issued an airworthiness directive ordering immediate inspections, giving operators of the highest cycle aircraft 7 days to comply, and any aircraft found with cracks was grounded on the spot. Around 50 aircraft were grounded worldwide. Qantas pulled 3, Gol in Brazil grounded 11, Southwest took 3 out of service. Of the first 500 aircraft inspected, about 5% had cracks. The timing could not have been worse for Boeing, because with the entire MAX fleet already grounded, airlines had been leasing and buying every spare NG they could find to cover the gap. Now the aircraft covering for the grounded fleet had a structural problem of its own. The 777X delays. Not a crash, not a fire, just a program that has been quietly falling apart for over a decade. Boeing launched the 777X in 2013 and told airlines they would have it flying passengers by 2020. It is now 2026, and the aircraft still has not been certified. Boeing is currently aiming for first delivery in 2027, which would put it about 7 years behind schedule and roughly 14 years after the program was announced. In October 2025, the company took a $4.9 billion charge on the program, which is the accounting way of admitting a very large amount of money is not coming back. Boeing has been careful to say there is no new technical fault holding things up, that it is the certification process taking longer than expected, and after everything that happened with the MAX, regulators are in no hurry to wave anything through. Meanwhile, the delays have created a strange secondary problem. Boeing built dozens of these aircraft between 2018 and 2022, back when it was confident certification would be straightforward, and those jets have been parked ever since. Now, the airlines do not want them. Emirates, which holds the largest 777X order at roughly 270 aircraft, has refused to take the oldest airframes. Lufthansa, the launch customer, has done the same. Aircraft that sit outside for years need inspection and rework before anyone will accept delivery, so Boeing has had to set up an entire separate production line just to bring parked jets up to current standard. The KC-46 tanker. Boeing's problems are not confined to airliners, and the clearest proof is a military aircraft most people have never heard of. In 2011, Boeing won a contract to build the United States Air Force a new aerial refueling tanker, the aircraft that flies alongside fighters and bombers and passes fuel to them in mid-air. Boeing based it on the 767 airframe and called it the KC-46 Pegasus. Crucially, it was a fixed-price contract, which means Boeing agreed to a set figure and would have to absorb any costs above it themselves. That decision has turned out to be extraordinarily expensive. The first aircraft arrived in January 2019, more than 2 years late, and the problems did not stop there. The core issue is a system called the remote vision system. On older tankers, the boom operator lies down at the back of the aircraft and looks out of a window to guide the refueling boom into the receiving aircraft. Boeing replaced that with cameras and screens. It sounded like an obvious modernization, but in real conditions, the image quality kept failing, with lighting angles, weather, and reflections producing distorted pictures. At one point, operators were reportedly using shadows cast on the receiving aircraft to judge distance. The Air Force classified it as a Category 1 deficiency, meaning a flaw that could cause death, serious injury, or major damage. The replacement system was originally hoped for in 2023. It is now expected in 2027. There have been other problems too. A refueling boom too stiff for lighter aircraft like the A-10, debris left inside aircraft during manufacturing, and fuel leaks. In February 2025, the Air Force halted deliveries entirely after structural cracks were found on new aircraft, with similar cracks then discovered on 21 of the 89 already delivered. By early 2026, Boeing had taken more than $7 billion in losses on the program. Boeing's own CEO described it publicly as a bad contract for the last decade. The Alaska Airlines door plug. 4 years after the MAX grounding was supposed to have fixed Boeing's problems, a piece of a Boeing aircraft fell off in midair. On the 5th of January 2024, Alaska Airlines Flight 1282 had just climbed out of Portland, Oregon, when a door plug separated from the fuselage. The cabin decompressed instantly at around 16,000. The noise was so loud that passengers and crew could not communicate, and the rush of air pulled loose items straight out through the hole. Some flight attendants initially thought passengers had gone out with. Nobody died, which was largely luck, since the seats beside the door plug happened to be empty, and the pilots got the aircraft back on the ground safe. 7 passengers and 1 flight attendant had minor injuries. The door plug itself was found in a back garden in Portland. When the NTSB finished its investigation about a year and a half later, the finding was almost hard to believe. 4 bolts holding the door plug in position had been removed during a repair at Boeing's factory and never put back. Photographs from the factory showed the plug closed up with bolts missing. The board blamed systemic failures in Boeing's manufacturing process, along with ineffective oversight from the FAA, and criticized Boeing specifically for failing to give factory workers adequate training and guidance. The Starliner Stranding. It may be the most publicly embarrassing thing that has happened to Boeing. On the 5th of June 2024, NASA astronauts Butch Wilmore and Suni Williams launched aboard Boeing's Starliner capsule on its first crewed test flight. The plan was 8 days at the International Space Station and then home. Problems started on the way up with a helium leak in the propulsion system, and got worse as Starliner came in to dock the next day, when 5 of its 28 maneuvering thrusters failed or started misfiring. Engineers were especially worried about seals inside the thrusters that appeared to degrade when fired at high temperature, and they could not fully examine them because the section containing them is designed to burn up on re-entry. NASA and Boeing spent weeks running tests while the astronauts waited. Then on the 24th of August, NASA made the call. Starliner would come home empty, and Wilmore and Williams would stay behind and return later on a SpaceX Dragon capsule. They finally got back to Earth in March 2025. Their 8-day mission had lasted roughly 286 days, over 9 months. It is the longest unplanned extension of a human spaceflight in NASA's history, and Boeing had to watch the competitor it had been bidding against bring its own astronauts home.